Good afternoon. Thanks, Mona. It's great to be here and to have the opportunity to talk to you all on behalf of the event sponsors, Murphy's, about the work we're doing for Project Alpha on the West Coast Main Line, upgrading the drainage asset, adding resilience to the asset out there to be able to deal with the extreme weather events that we've heard so much about today. Let's just see if I can figure out this clicker. So, I'm going to go into a bit of background, why we're doing what we're doing. And obviously this morning we heard so much about the problems that are out there through Mona, through Julian, the challenges we've got with our infrastructure, climate change, availability of funding, and also probably another topical one that Gareth mentioned as well was those sort of reduced opportunities to get out there and do work on the infrastructure. We've heard about some innovative products. We've also heard about planned and sort of reactive works that we can do. The innovation within this is probably more how we get proactive solutions onto site as quickly as possible through design and then into the delivery of that. I'm going to have a look at the schemes that we've delivered through Project Alpha in terms of drainage, and then circle back around and have a look at the impact of those and what the benefits were of that delivery method. So in terms of where to start, probably what is Project Alpha would be a good place. Back in 2018, the ORR was looking into deteriorating train performance and challenged Network Rail to improve its management of the track infrastructure. Project Alpha was formed in response to that as a Network Rail initiative to improve performance and ultimately customer service. Looking at common cause of delay and the impact of extreme weather events. In 2020, Network Rail came to Murphy and asked to assist with the West Coast Flood Alleviation Programme, with the idea being to sort of plan and implement drainage in an accelerated way. In terms of what we've done around design, as I've said, we wanted to get the sort of benefits from these assets as quickly as possible, so we need to get to site as quickly as possible. So we needed a new approach to the design process, which probably a lot of people in here will appreciate can be quite slow, quite painful. So where possible, designing to schematics against having detailed calculations where the complexity would allow. Meetings are nobody's favourite thing, but when you've got quite a forward-thinking client in Project Alpha, and getting the relevant stakeholders to the table, having those regular meetings with the right people in the room, in terms of land access, planning, trains, you're able to come to construction decisions within the meeting. It's not a meeting for a meeting's sake. There's real sort of tangible benefits for that, and then there was good collaboration. We had a fixed date in mind for when we wanted to deliver. We knew what we wanted to deliver, and in terms of those kind of review and acceptance periods for documentation, which can take up to sort of 28 days, it was agreed from the outset that those would be condensed down to 10 days to keep the momentum of the project going, and that sort of on average resulted in us be able to get from remit to AFC within sort of 3 months, which is around about half the usual. In terms of what we then brought to the table when we got to site, as mentioned, we had a really good client, had some clout in terms of getting us access to the track. We weren't working within rules of the route. When we go into the case studies, we'll look at the benefits of that and what we were able to do differently, but we had disruptive access secured. So as the construction contractor, we had to make the most of that access. So we would adapt the way that we work to really sort of get the most out of that. In terms of installing an awful lot of drainage, you're also interfacing with the rest of the system. You're affecting those assets. We need to be able to sort of monitor those and give assurance to the asset owners that they're still fit for the operation of trains, that they're not deteriorating. Quite often you'll do that through a monitoring regime, but if you're talking about kilometres and kilometres of drainage going in, that's not logistically possible, it's not feasible. So instead of being reactive to the degradation of assets, we got on the front foot and we were proactive, and we were putting that consolidation in the track, putting it back to an optimal position before we handed back to traffic, and we kind of developed a track interface plan to record that and agree that in advance. In terms of actual delivery, you can see we were using a couple of excavators on site. One was removing the bulk of the material, and the other one was then tidying that up to finished level, and that allowed us to get a good sort of conveyor belt system going. And also, as you can see in the picture, materials were in and out via rails, so we didn't have to waste a lot of time getting things up to site. So the first scheme we delivered, the first drainage scheme we delivered for Alpha was back in March 2021 at Crick. For anyone who knows it, knows that's up near Northampton. The challenges specific to this one, as you can see, working in and around the tunnel, shallow existing drainage, under-track crossing connections. What we actually did, we jet and cleaned almost 600 yards of 6-foot drainage through the tunnel, sort of improving that existing asset. We also renewed 550 metres in the downcess, 550 metres in the upsess, installing UTX connections, bringing both of those systems together, and a 40-metre connection then into the existing 6-foot drainage through the tunnel. As I mentioned, in terms of proactively protecting, restoring that track asset, we tamped almost 3 kilometres of track as well. Going back to the benefits of delivering this way, if we were to deliver rules of the route, so a standard Saturday night shift based on sort of 30 metres, optimised 5 pipes in the ground, it would have took us 9 months back to back at a cost of almost £2 million. And another metric that we've included here is sort of carbon emissions in scope 1 direct fuel. And what that would have looked like for 9 months of being mobilised to site, it is over 100 tonne of carbon. Whereas delivering it over those 4 or 5 days, we got in over a kilometre, 27% less in terms of cost for delivering over the 9 months. And the big win really here is 91% reduction in scope 1 carbon emissions. The second scheme was at Kensal Green down in London through the summer of 2021. It's London, so in terms of your restricted access location, difficult to get land to set up a site compound, difficult to store materials. As you can see from the picture, we were working there with adjacent lines open, so there was sort of safety things to take into account. Did really well. Disruptive access in London, there's obviously going to be a lot of other projects that are wanting to work in there as well, so we had to integrate with those, make sure that we didn't negatively impact each other. Again, shallow existing drainage to tie into, to take into account, tunnels, all that sort of good stuff. What we got in at Kensal was 882 metres of slow line, 6-foot drainage between the slows, 1.22 kilometres between the fasts, a twin track UTX connecting those 2 runs together. Because that run and the existing levels forced us to have shallow drainage, we also installed 20 sleepers with under sleeper pads. A lot of people know all about those though. Tamped over 2 kilometres of track again. Added value, in terms of added value while we're there, cleared a lot of vegetation, a lot of graffiti, actually installed some new access points and cleared a lot of legacy scrap rail out the way that's just difficult to get to. Again, if this was delivered over Saturday nights, 16 months worth of work, over £3.5 million. Again, 184 tonne of carbon through scope 1. Project Alpha over the sort of 12 days, 24 shifts that we were there, over 2 kilometres of drainage in, 21% less cost, and again, almost 90% reduction in carbon emissions. The start of January 2022, so I was moving up north, up to Kilsby on the Lex. Again, tunnels, it seemed to like giving us tunnels, Project Alpha. First day back after Christmas, really, 3rd of January, very wintry, you can probably make out from the picture, a lot of ground frost, difficult excavations, shallow UTXs again as well. So we put in 1,800 metres of cess drainage, 90 metres of 6-foot, 4 under-track crossings. Unique to this one, actually, we renewed 1,800 metres of S&T troughing as well while we were there, so helping out, signalling brothers. 2 kilometres of affected track was tamped, and again, a lot of legacy scrap rail removed that was just knocking about there. Probably in terms of cost, this was the best one, really. 55% reduction, 3.3 million down to 1.5. 15 months worth of work delivered over 9 days. And again, 166 tonne of direct one carbon was replaced with us emitting just under 17 tonnes, so again, 90%. Christmas last year, just before Christmas last year, we were back down in London. You see, we're zigzagging up and down the country. into Harlesden, if anyone knows it, on the CWJ lines. London again, not very much land to work with. You can probably make out on the picture there, this is the tracks are in between two retaining walls. Originally the scheme was designed to be cess drainage, but partway through that sort of design process, the structural asset engineers weren't too keen on us opening excavations against those walls. So much to our dismay, it became 6-foot drainage for the reasons you can probably see in the picture. You've got DC equipment, you've got signalling equipment, the last things you really want to be putting a bucket into. We also had industrial action going on just before Christmas last year as well, which had a lot of impact on possessions and being able to do surveys and all sorts of stuff, worrying about whether we'd get our trains to site to deliver the works. Nonetheless, 752 metres of 6-foot drainage went in. We actually took out the DC equipment, just took it completely out of the equation, removed the risk, reinstated that in the S&T afterwards. Over 1.5 kilometres of track was tamped, which is also a benefit to the track maintenance engineers. Again, lots and lots of scrap rail was cleared out all around that area. So what was 6 months worth of Saturday night only working, and to be honest, that's probably optimistic as well. If anyone knows the possessions you get around there, once you've took into account the DC isolations, you're not going to get 5 pipes in the ground on a Saturday night. So you could probably call that 9 months, 12 months worth of work, delivered over 14 shifts, 30% less money, came in under the million. And from 66 tonne to just under 13 tonne of carbon, so 81% reduction. We also took this to Harbury. I think we saw a picture of Harbury earlier on. I think Julian shared that. Well known to everyone in here for instability of its earthworks. It's also got drainage issues. Buried services also, cable UTXs and things were where we wanted to put our drainage. There's a triple SI there. We had a week there. We were able to get 550 metres of cess drainage and tamp 730 metres of the track there as well. For this one was a bit different. You'll see like the cost isn't so impressive and everything else, but we actually had to dismantle the work site. We had to backfill everything and stand down to pass engineering trains from another project halfway through and then remobilise and get going again. So that probably hit our outputs and thus our cost, but nonetheless, 4 months worth of work was delivered over 4 days, really, 8 shifts. And still, we're in and out. So there's a massive reduction in carbon coming out of our compound and our plant. The most recent job we've delivered, you'll be pleased to hear, it's the last case study I've got for you. Stonebridge and Harlesden, so back down on the CWJ lines. This was was a week in August this summer. London again. All the sort of things I've told you already, built up urban location, third rail, S&T equipment. We also had platform interfaces through Harlesden Station. And again, there were plenty of other significant projects working around us that we were, integrating with. 591 metres of cess drainage, twin track UTX, just under 250 metres of 6-foot drainage installed through Harlesden Station. And other areas of the Murphy business were out working in the same axis as well, delivering a lot of platform resurfacing schemes. The third rail was in and out in this, as well as S&T equipment, tamped over 1 kilometre of the track that was in and around where we were working. Probably the most scrap rail came out of this one as well. There's a lot of scrap knocking around Wembley, Stonebridge, all those places. 7 months worth of weekends, which again is probably very optimistic, delivered over the week. A third less cost, and an 83% reduction in Scope 1 carbon emissions. In terms of the asset management, when you're putting in such a large quantity of drainage, someone needs to know about it. Somebody needs to be looking after it. So towards the end of our access, we get all the relevant stakeholders out. We have a substantial completion walkout. That way, if there are any issues or if any sort of snagging becomes apparent, you've got a bit of time to sort it out. We're not having to try and come back in months down the line by the time we've met access planning requirements. The new assets are also captured using the Polestar system. Some may be familiar with that. So as things are going into the ground, they're being photographed, they're being geotagged, and then they're uploaded and they're being maintained. Health and safety file and handover is just conducted to normal timescales. Once the job's done and the asset's realised, it's being maintained. There's no benefit to rushing that. That's got to be done properly. So I did say I'd sort of circle back around and have a look at the Project Alpha overall. So, you know, you've probably seen the way the wind's blowing on that one in terms of output, cost and carbon. But yeah, very much that 30 metres was based upon the time that you're losing on a normal Saturday night. You know, everyone loses an hour at least off the start of a possession, the end of a possession. You're having materials delivered that then need to be transported up to site. You're getting machines on and off. So that's the reason for that. The carbon, whilst the figures are impressive, they're only based upon direct fuel, which is, you know, the diesel we're putting into our plant, that, you know, whatever's going into the site compound, that's not taken into account. You know, a workforce travelling up and down the country every weekend and all the sort of fatigue risks that are associated with that. What we also didn't account for is the engineering trains. We brought the materials in and out via rail, which is obviously a massively more efficient, environmentally friendly way of doing that by road. But also we weren't taking, you know, wagons in and out of central London, inconveniencing everybody like that and just causing chaos really. So if you wrap it all up together, if we were delivering those schemes Saturday night only and you put them all back to back, you're over 4.5 years worth of work bank there. You know, over £12.5 million and emitting 721 plus tonnes of carbon. Again, that's probably conservative. Whereas, you know, working for the Project Alpha client, we've installed 7.274 kilometres, very accurate. An average of 83, nothing but accurate engineers. Average of 83 metres per shift, which is almost triple what you can expect of a rules of the route shift. And if they were to be tailed end to end, you've delivered that in 3 months, which is 95% less than the 4.5 years plus. Overall, 31% reduction. You can see it there, just over 8.5 million versus 12.5. And again, it's averaged out about 90% less carbon from that kind of in and out strategy. So probably to pull some sort of conclusions out of our learning for working for Project Alpha, if at that remit stage you can engage with a forward-thinking client, if you can get engaged with the asset owners, the people who deal with land access and trains, and you can put buildability at the forefront of what you're doing, and you can get those benefits in terms of your output, your efficiencies, your cost, and sort of like your environmental contribution really as well, which obviously will hopefully reduce the damage that we're doing and the consequences we'll face. That's me. Thank you very much.